here to the inaugural Coulter Case lectureship in biomedical engineering. I'm going to give you a little bit of background about the Coulter program, the Coulter partnership at Case, and then we'll get on with the lecture. This is the first lecture that this partnership will be sponsoring. Okay. In 2006, we began what we're calling the Coulter Case Translation and Innovation Partnership. This is a result of a grant from the Wallace H. Coulter Foundation to establish a program in biomedical engineering that would foster the translation of fundamental biomedical engineering research into clinical products that would benefit people. Wallace Coulter, as many of you may know, was the inventor of the Coulter principle, which was a technique for estimating particle sizes that he developed and which he translated into the commercial product, which was a blood cell counter, the so-called Coulter counter. He and his brother started the Coulter Corporation, which commercially produced this device and marketed it for the benefit of everybody around the world. Wallace's deepest passion was to improve healthcare and make these improvements both available and affordable to people around the world. When he died, he established through his estate the Wallace H. Coulter Foundation and left the leadership of that foundation up to Sue Vann, who was his trusted colleague from Coulter Corporation. The foundation's objective is to improve healthcare through the biomedical research and engineering. To accomplish this, the foundation set up what they called the Translational Research Partnerships, and Case was the recipient of one of these partnership grants. The grant is about $4.5 million spread over 5 years, and each year it funds several projects that are put together by teams of biomedical engineers and clinical practitioners, practicing clinicians, to address an unmet or a poorly met clinical need through biomedical engineering. The project proposals are rather unique for research proposals in that they have to address not only the underlying science and engineering, which is what all academicians are really trained to do, but they also have to address the product concept, the clinical need, the competing solutions in the competing intellectual property, the size of the market, and the potential for commercialization. These are new proposal elements that most academicians are not used to. The projects are also selected by a team that is very unusual, an oversight committee. This committee consists not only of engineers and research engineers and scientists, but it includes tech transfer specialists, clinicians, venture capitalists, leaders in the biomedical industry, and a member of the Wallace Coulter Foundation. We also draw very heavily on bioenterprise to help us in our attempts to commercialize these projects. It's really in recognition of the need that for any new project like this, in order for it to have an impact on people and become available, it has to be commercialized. Translational research is really changing the academy and the academic profession. Society really now expects that the government funding of research in universities will result in practical benefits to society and also to economic development. At the same time, industries are shrinking their research budgets in-house, and this provides an opportunity. Those universities that are successful in balancing strong fundamental research and translation and innovation will really be the future academic leaders. And that's what this Coulter program is all about. The goal of the lectureship is twofold. One is to bring attention to this partnership, and we will also, by the way, we will have the call for proposals We were supposed to have it here today, of course. We don't. It'll be on the website, and you can find that pretty easily from the BME website. The second purpose of this lecture is really to provide examples of academicians who have really successfully accomplished translational research and commercialization. And our speaker today, James Wyant, is really an outstanding example of this new breed of academic. And now I'd like to transfer this introductions over to Norman, translate the introductions over to Norman Tien, Dean of the School of Engineering, who will introduce the speaker.
I certainly don't want to be Dean of the School of Medicine. Pam Davis is doing a great job. But no, I have the great pleasure of introducing our speaker today. The title of the talk, at least the first part of the title, is From Professor to Inventor to Entrepreneur, and I really cannot think of a better person to talk about that than James Wyant. He is right now the Dean of the College of Optical Sciences at the University of Arizona. One institute that program that I know is really one of the top programs in the world in the optical sciences arena. At the same time, he, back in the 1980s, founded the company WYKO, a laser interferometer company, which grew to a very healthy corporation that was eventually acquired by WYKO, which is a huge company in itself. I'm sure he will talk about some of this, some of his activities in this area. Numerous awards I won't really go into. What struck me as I was coming in, of course, Pat Crago talked about this particular lecture series and the Coulter Foundation. I noticed a lot of athletes are also in attendance in this room, and so perhaps the title of the talk should almost change to From Athlete to Professor to Inventor to Entrepreneur. James Wyant, of course, is one of our own. He graduated in 1965 from the Case Institute of Technology and Physics. But more importantly, perhaps, he was also captain of the cross-country team back then, and I think had wonderful experiences in the athletics program here at Case. So without much further ado, let's welcome James Wyant.
Okay, well, thank you very much. I really feel honored being invited back here by Case and by the Coulter Foundation to give this lecture. I learned a little more today about the program that Coulter Foundation has with Case, and it certainly is a very impressive program, and I would certainly encourage as many of you as possible to become involved with it. There's so much great technology being developed at a university such as Case, and it's nice that a foundation like Coulter is trying to get that technology out into the world to help mankind. So I think it's really great what they're doing. Before I get started, I would like to thank Professor Bill Gordon, who was an old professor of mine a couple of years ago, for coming to the lecture. And in honor of you, Bill, I think I'll give a quiz at the end of the lecture. So how many of you are athletes? Okay, quite a few. There's some question whether I was an athlete or not. I did run track and cross country, but fortunately I was better at some other things than I was at running. But it was a lot of fun, and especially because I love to compete. And that was the great thing about track and cross country. And Coach Sudak, who recruited me in Howard Johnson's restaurant as I was eating a hot fudge sundae, I certainly have to thank him, because when I came to Case, I did not plan to run track or cross country, but he invited me to practice, and of course I didn't show up, so he called me, and I didn't show up, and he called me again, and I decided, well, I better show up, and so I ran track and cross country for 4 years here. So another question is, how many of you would like to start a company someday? A few, yeah. I mean, can be an absolutely wonderful experience. It can also be a lot of work. But it's a lot of fun. And I can think of nothing that in my life it's been more fun than starting and growing and then finally cashing out of a company. It's just a fantastic experience. And so what I'm going to talk about today is to talk about how I started this company and how we grew it and then how we cashed out. And then at the end, I'll kind of give you some of the lessons that we learned. So this company grew out of my laboratory at the University of Arizona. And we made instruments, interferometers for any physics majors here? Yeah, not? Oh, okay. Well, we made interferometers for the measurement of surface roughness and surface shape. And we sold these into a lot of industries, the machine tool industry, automobile industry, optical industry, medical industry. And where the biggest sales was in the hard disk drive industry. Essentially everyone in the world who made hard disk drives that you have in your computers or iPods, whatever, used our equipment or still use our equipment for the testing of these hard disk drives, the flatness of the disk and the shape of the recording head. So let me go through here and say a little bit about the founding of the company. It was founded back in 1982. But if I really think about it, it started before that. And after I left Case, got my degree here in physics, I went to University of Rochester and got my PhD in optics at the University of Rochester. And then I went to the iTech Corporation in Boston to work. And I worked there from 68 to 74. And it was a wonderful experience. And really the work I did there led up to WYKO. The great things about the job, well, first off, I had the freedom to do what I wanted to do. I mean, a tremendous amount of freedom. We had plenty of money for equipment. What iTech did in those days was to make spy cameras up in satellites, and they made a ton of money. And I didn't have to work on the spy satellites, but I got to play in the R&D lab and had plenty of money for buying equipment. Had wonderful, very smart people to work with. Extremely important to have. And the last item here is that we had marketing people who brought interesting problems to us. And if we wanted to work on these problems, we could. And if we didn't want to, we didn't have to. But during this time, I got involved in the very first experiments on adaptive optics. That was for correcting for atmospheric turbulence. It's commonly used in the astronomy industry now. At that time, we were using it to trying to look at Russian satellites. I guess nowadays, if you want to see a Russian satellite, you can go out and buy one, but back in those days, you couldn't. And so we had to some way see the satellite as well as we could, and we had to get rid of the effects of atmospheric turbulence. And so worked on that, and that led to something called phase shifting interferometry, which I mean, in interferometry, we're comparing two beams of light. I mean, interferometry was made famous here at Case Western Reserve by the Michelson-Morley experiment. And, but interferometry is used to measure, you can interfere two beams of light and get these interference fringes that will tell you how the shapes of the beams. And phase shifting interferometry was basically a way to get the data about the interferogram into the computer. But back in 68, 69, when I first began working on this, it was completely useless because we didn't have the computers we needed. We didn't have the electronics we needed. We didn't have the detectors that we needed. And so the idea, kind of sat dormant in my mind for several years. Well, in 74, I went west. I joined the faculty at the University of Arizona, and I did the thing that, normal faculty members do. Brought in research funds, wrote papers, taught classes, and got tenure and promotion and so on. And by the early 80s, I was a little bored with what I was doing, and I was kind of looking for something else to do. And I always was interested in starting a company, so I wanted to start a company. But to start a company, you have to have an idea. You have to have a product. Well, I didn't have any I didn't have a product. But an idea came along in 1981 to me. And at this time, I was visiting a laboratory in Oak Ridge, Tennessee, where they were making optics, diamond turn mirrors for laser fusion systems. And these mirrors were made on what was basically like a milling machine. And they were not very smooth. They had grooves in them. And so they had to measure how deep these grooves were. And they had set up a whole row of interference microscopes. And they were taking Polaroid pictures of these interference patterns, all these little lines, and trying to measure how straight the lines were. And they had a whole bunch of people all day long, were taking these pictures and using a ruler and measuring how straight the lines were and calculating how good the mirrors were. So I said, there has to be a better way of doing it than that. So I went back to Arizona, and I first went to some friends of mine at Los Alamos and told them I wanted to work on a better way of testing these mirrors, and I convinced them to give me a little money to do research in that area. And then I went out and I found the best graduate student I could find to work on the project. And so we began kind of fumbling around, not really knowing what we were doing, but trying to come up with some way of measuring these mirrors. And I got to thinking back about this thing I'd done back at ITech many years earlier on phase shifting. And I said, maybe this is more practical now. Little computers, you'd probably consider them more as calculators now than computers, but at the time we called them computers. Computers were becoming available, and electronics was better, and there were some solid-state detector arrays that were beginning to come out. And so we kind of came up with a method of using an interference microscope for measuring the surface quality of these diamond turn mirrors. And this is not going to be a technical talk, but I have to show a couple of pictures anyway. So basically, it's a microscope system, a nice white light illuminator, and a little filter to pick out, in this case, red light. And down here was what the sample we're looking at. And this was an interferometer, so light would come down here. Some of the light would reflect off of here up to a reference surface, back down here and back up. And some would go down to the sample, back up. So we got these interference fringes we wanted, and they fell on this detector array up to the top. And so we would interface this detector array to a computer, and the computer also moved this mirror. Because in phase shifting interferometry, what we want to do is take a lot of measurements as we change the path difference between the reference beam and the test beam. And so this little translator, piezoelectric transducer that the computer controlled the voltage to would move this, and we could get the data inside the computer as to what the surface shape was. And unfortunately, I don't have a picture of the very first system we built. And, in those days, I didn't take pictures of things. I tell you, if you're ever going to start a company, take pictures of everything. Because later is when you give talks, you need those pictures. And I don't have them, but I do have, in my garage, I say first, almost, well, second or third something. This was a prototype. This was still at the university before starting the company. A prototype of this system to measure surface roughness of these diamond turn mirrors. So this was great, except it really didn't work. The data that came out of this was just kind of random noise. It was terrible. And I still remember taking it to an Optical Society of America meeting in Orlando, Florida, and showing it off. And only one person, I showed it to a few hundred people. Only one person realized that the data coming out here was garbage. Because kind of the thing that was saving me was that it was so slow that people would watch it go through it once. They wouldn't watch it measure the second time, because if you saw it the second time, you realize it wasn't the same as the first time. And so, but anyway, people were excited about this. And this was something that people, kind of wanted. The only problem was it didn't work. And it didn't work, the optics, we understood the optics well. And even the mechanics wasn't bad, but the electronics, we did not understand the electronics. Well, then I got two gifts from heaven, okay? The first was the electronics guy. I got a letter, it's days before email, I got a letter from a man in England who wanted to be a postdoc, and he knew electronics. And so I immediately wrote back and said, yes, we'd love to, I'd love to have you as a postdoc. And he really did know electronics. It turns out he was fantastic at electronics. He had a great personality. He was a great salesman. He was a great marketing person. He was wonderful, okay? So that was really the first gift. The second gift, well, IBM has a facility in Tucson. And I guess the executives at IBM felt, at the university, they must be doing something useful that we can use. And so they asked this man, Bharat Bhushan, who actually now is a professor down at Ohio State, but back then he worked for IBM. They asked him to come to university and see if he could find something that would be of interest to IBM. Now, what Bharat did was he was interested in magnetic data storage, and he was working with magnetic tapes. So he wanted to know, he asked me, and I showed him this instrument. He said, well, would this instrument measure the roughness of magnetic tape? And of course, I had to say yes, And so he gave me a sample, and we measured it. And the fortunate thing, if you ever look at magnetic tape, the roughness, it sort of looks like a random function. And so the data coming out of this instrument was great, because it was kind of random noise. This is a true story. So, I have to say he worked me to death. He gave me so many samples to measure. I remember once at 10 o'clock at night, on a Sunday night, I got a phone call from him. He says, I need to have some samples measured for a meeting tomorrow morning. And I had the microscope at my home, of course, playing with it. And so he brought the samples over, and I got the measurements for him. And they weren't very good, but there was a little correlation between our random noise and what it was he wanted. And so he decided, he said, we want to buy one of these instruments. And I said, oh, this is great, And he said, how much? I said, $100,000. I had no idea what it cost to build, but I said $100,000 seemed like a nice number. And I said, but we don't want to sell it through the university. We've started a company called WYKO. We want to sell it through WYKO. And we need 60% of the money up front to purchase parts for the microscope. He said, okay, so he'll do it. And a few weeks later, I got a check in the mail for $60,000. And so I was so excited, we got our down payment. And so I went off to the bank to cash a check. But the problem was I told him we had started a company called WYKO, but we hadn't actually started a company called WYKO. And so when I went to cash this check, they wouldn't allow me to cash it, okay? Because there was no WYKO. Well, that was fixed. We started WYKO then, called it WYKO Optical Inc., and started it right at the end of the year, December 27th, 1982, which also was not very smart, because then 4 days later we had income tax we had to worry about, but should have waited. But anyway, the four of us started it. Chris Koliopoulos was the student of mine who had done this work for his dissertation. And that's, the W-Y came from my name, Wyant, and the K-O came from his name. And Steve Lang, who was a research associate working for me. And Keith Prettyjohns was the postdoc who knew the electronics, and then myself. But, three of us, well, Chris had gotten his PhD, and he had stayed on as an assistant professor. So Chris and Keith, who was a postdoc and loved the university, and myself, we didn't really want to leave the university. So the great idea we had was that Steve would leave the university, and basically Steve was going to do all the work. And we would stay, That didn't work too well. But anyway, that's what we did. So we started it that way. And I no longer could do this in my laboratory at the university. In fact, I probably had already done too much more there than I should have done. But so we rented a small suite, and I tell you that it's much smaller than this stage, the room we rented at this building. But anyway, we were off and starting a company, and we had basically two goals with this company. First goal was to have fun, okay? And the second goal was to make money. Now, I think to really be truthful about it, the real goal was to have fun. You know, I kind of wanted to make money too, but the real goal was to have fun. But anyway, these were the two goals. But the problem was we were not having fun, and we were not making money. Because this thing we sold to IBM would not work. And so we couldn't ship it. And so every month I would have to send this letter to the purchasing agent at IBM and say, well, unfortunately we're not able to ship it this month, but we'll ship it next month. And then next month would come along and I go into the computer and change the date on the letter and send it again. So something had to happen. So September 1984, almost 2 years later, I just said, this cannot go on, because it's a failure. That either I'm really going to have to go there and really put my life into this, or we're going to have to just fold up the company. Well, I didn't want to fold up the company. And so I went to WYKO, nearly full time. Now, what I did, though, was that I continued 20% time at the university. And I stopped doing all research at the university, but I continued teaching. And I would teach a course a semester, generally each semester, sometimes it'd be one course per year, but most times it was a course a semester. And then I went to WYKO, and I really did work. I mean, I was going to do it for 2 or 3 years, but it lasted 13 years. So for 13 years, I will have to say I worked 7 days a week. I really worked hard. But I had a fantastic amount of fun. The other thing that happened at this point was that Chris left the company, and I thought this was kind of a terrible thing, almost like a divorce, to have Chris, who had been my student and then with me at the company. But we just couldn't agree on things. And now I realize that so many companies, the founders, they split up after a period of time. Just you have different interests and so on. And he left and he went on. He's done very well in his career, but he left WYKO at that time. But then we really got serious, and we rented another space here where we could actually do some work. We had a couple of thousand square feet here. And while we were in this building, we actually changed the name from WYKO Optico to WYKO Corporation. And the reason we did that is that there were 2 buildings here side by side. And in the second building, there was a dentist and a foot doctor. And so people, seeing WYKO Optical, we had lots of people coming in to buy eyeglasses. And which actually might have been a better business for us at the time. But we said, we don't want to go in this eyeglass business. So we changed it to WYKO Corporation. Now, some of my former best friends say it should have been called WYKO. But anyway, things began to take off then. I mean, really put your work, your mind to it. If you work hard, then the other people who work with you will also work very hard. And we developed this instrument. We finally, after about 2 years, we were able to deliver to IBM what they had purchased and what they had paid $60,000 down for. And so we built this thing, which was, this is such a nice instrument. I have a big picture of this in my living room at home, because we sold thousands of these at prices ranging from $100,000 to a couple $100,000, depending on the accessories. And we were able to measure these diamond turn mirrors. So this shows the height as a function of position across here. And we were able to measure things down into the angstrom or even sub-angstrom range. This was a great instrument. We could measure over areas, and we sold a lot of these. We sold so many we had to expand, so we needed more space. So we rented this space, and this was beautiful. It was right across the street from the university, and I could work here and walk across the street and teach a class, and then come back here. And we had several graduate students who'd be working for us here. I mean, it was so convenient. It was great. And we developed several other instruments at that time. And one was what we call the WYKO 6000. This was an instrument for testing of optics. But it ended up being a financial disaster because on June 30th, 1988, I got a letter which someone had filed a patent lawsuit against us. At the time, I thought it was a joke because I knew about the patent. Well, they actually sued against 3 patents, but 2 of them were just completely, there was no question of what we weren't doing any of that. But the third one was one I knew about, and I'd gotten an attorney's write-up on what we had to do to not infringe that patent. And we did what the attorney told us to do. So we really felt we were not infringing the patent. So I have to say I made a mistake, and I didn't really take the lawsuit very seriously for a while. But after paying the lawyers a couple $1 million, I took it much more seriously. And it dragged on for nearly 10 years. It went on forever. And took a lot of time plus a fair amount of money. But you know, in a way, it helped us because until this point, I never thought much about patents. I always thought you had to have a Nobel Prize-winning idea to have a patent. And I saw this rinky-dink patent that was driving us crazy. And I said, you know, we need patents. And so we began filing patents. And so by the time we sold the company, we had some 45 patents with more in progress. And some of these patents are really pretty valuable. And so this lawsuit, while it cost a couple $1 million in legal fees to fight it, I'd have to say it probably made us a lot of money because of the patents that we developed, because I suddenly woke up and said, patents are important. So if you remember one thing from this talk, patents are important, okay? Well, we grew and we ended up buying a former IBM building. It was about 110,000 square feet down by the airport. We grew down there. That gave us good space to grow. And we developed other products. And one I'll mention here is, well, it's similar to what we had before, except we took out a filter. And we're using white light techniques. I mean, nothing that Michelson didn't know here at Case a long, long time ago. And it was an idea that, again, I thought of about 20 years before. And it's sort of like OCT, for those of you who are familiar with OCT. But OCT for measuring the heights of surfaces. But you know, when I first thought about it, it wasn't practical. We really didn't have the computing power that we needed. But later, by the end of the 80s, the computing power was there. And it really opened up the product line, the applications much more. And we, this is one of the systems that we sold. So basic microscope system, you can't see what's inside. But using this new technique that was similar to OCT and then computer interface to that and a tremendous amount of software, and we could measure all types of surfaces now. Not just smooth surfaces like we could do before, but we could measure both smooth surfaces and surfaces that departed a lot from being smooth. You know, here's a step that's like 48 microns high. Previously, we couldn't measure that, but that was no problem. Well, here's a nice application in the printing industry. This is a print roller that has little pits in it that holds ink when you're trying to print, and it's important the size of these little pits. And with this instrument, I mean, we could measure that. That was great. I mean, we could measure paper roughness. I mean, it's just opening up all kinds of markets for us. Micro machine surfaces, a little micro machine piece of silicon, binary optical lenses, IOLs, artificial heart valves. We did a lot in this area. Machine tool industry. Well, this is a Saturn engine. We could measure inside the bore of the Saturn engine, and this is showing the honing marks and so on. This technique was so much better than what they previously had, but we sold almost none into the automotive industry because we ran into problems with the unions, and the people said, you know, I've been measuring this for 30 years this way, and I'm not going to change. And even though what we had was much better, we didn't sell much in that industry. But the other industries were great. Data storage industry, you know, essentially everyone in the world in the hard disk drive industry was using our equipments. Semiconductor industry was fun. Lots of products. Well, the next product I want to show you is something that didn't make money. It lost money, but it had so much fun. I have to show this to you. I remember we had two goals, you know, have fun and make money. So this one, next one was the having fun part. And it was a technique that's been around for a long time, but we essentially applied some modern electronics and computers and software to it. And if you project the lines, a bunch of lines onto a surface here, and view it from some angle, you can measure the shape of the surface, it turns out. And we applied these phase shifting techniques that I talked about before, and to measuring this, and you know, essentially added some electronics and computers and so on. And we could measure things like a can or a Coke bottle, shape of that. You could measure your hand. You want to measure the shape of your hand. This is the shape of your hand. And then my favorite one, you could measure the shape of your foot. Now, why is that my favorite? Well, one day we had a person come to WYKO, just came in off the street, didn't have an appointment or anything, you know, never had customers like that. But he came in and he wanted us to do something for him. But he was so secretive, he wouldn't tell us what he wanted us to do for him. And I talked to him, I couldn't find out, he just wouldn't tell me. So I thought, well, you know, this is a waste of time. What I'll do, I'll give him a tour, and I'll end up by the front door and then say goodbye to him. Well, on the tour, we went to where we were doing these projected lines things, and he got all excited, and he took his shoe off, and he took his sock off, and the table was just right. He held his foot up and said, measure this. And I pushed a button on the computer, and that's the actual measurement. The very first try, it worked. I didn't try the second time because it worked, you know, first time I didn't. But this led to a joint venture. And what he wanted to do was he wanted to use this for measurement of people's feet for making orthotics. And I guess if you get an orthotic the normal way, you put plaster on your foot, and then they send the plaster mold off to some lab and they make your orthotic. But his idea was we do this, and then we, you know, send that over the, well, internet wasn't so common yet, but we were going to send it over the phone lines to a lab that had a milling machine, and then they would FedEx the orthotic back, and so you'd have it the next day. So it sounded like a great business to me. And we developed this foot scanner. And I mean, it worked extremely well. But the problem was, I failed. I didn't do the right. I didn't do any marketing research as a problem. That's what the failure was. For us to make decent money on this, we had to sell these for $12,000, and the podiatrists were willing to pay $2,500. And so we sold a very small number. And in fact, I still have 2 of these in my garage. And if any of you are interested in a deal, you know, you can see me after the talk, and we can work out a special case deal for you, okay? Anyway, so that didn't make money, but it was a lot of fun. Fortunately, the other things worked out better. You know, and we had sales offices around the world. We sold a lot of products to different places. And we had a number of patents. As I said, I think at the time we sold the company, we had like 45 patents and won a number of awards. And so, it was fantastic. But I truly was working 7 days a week. I really did put a lot of time. But it was fun. So it wasn't quite like work, but I was getting tired, I'd have to say. So as I said, we started this the end of '82. And then I'll say, sort of the end of '84, we got serious about it. And although at that point, Chris left, and actually as time went along, the other 2 founders left. It wasn't that we had problems. Well, they got tired. They wanted to go off and do something else. So the other 3 founders left the company. And we didn't go out for venture funds at the beginning. Remember, IBM financed it, and then several other companies that we would get some initial money from. And so it was all internally funded. So we ended up, I owned the place, was a nice thing about it. And, but I was getting tired. And so in '97, I sold it to a company called WYKO. And I mean, this was tough to do. I mean, well, it's sort of like, you know, you raise a child and the child gets up and leaves and goes off on their own. You know, this is sort of what I was doing here. So it was tough to sell the company, but at the same time, I was tired. I wanted to go back to university. I thought about hiring someone to run the company, but I knew that I would still be worried about it all the time, and I just couldn't let go. The only way to let go was to sell it. And so I sold it to WYKO. And I would say it's one of the best things I did. I went back to university and became a professor for a short period of time, and then became the head of optical sciences. And then when optical sciences became a college, I became the dean. So it's worked out well. So I'm very happy. So what I want to do in the last little bit here is to say a little bit, you know, surprises, what did I learn, and so on. So what are the biggest surprises? There were a lot of them. The first is the difference between a research project and a product. I mean, doing a research project, you make something, you make it work once, you get some data, and you publish it. But you have a product. I mean, it can't work just once, and you can't require that it be a PhD to operate it. You have to have something that you can put in a box and ship halfway around the world, and someone can take it out of the box, someone who barely reads English can take it out of the box, and it works. And it keeps working. And I tell you, that is hard to do. That's a tremendous difference there. So I certainly learned that the hard way. That's why I don't have much hair left at night. The other is, you know, you say, well, this costs me $20,000 to build, so if I sell it for $25,000, oh, I'm making $5,000. This is fantastic. But, you know, you think about it, you know, you had to develop the product, you have to build prototypes, then you manufacture it, you have to sell it, you have to service it. So there really is a big difference between the cost of the, you know, the difference between the cost of the parts for the product and the cost to design, produce, and maintain it. So you have to sell it for a lot more than what the cost of the parts are. And you have to make enough money that you can really provide good service on it too. I think that's very important. The other is, you know, the amount of money it takes to run a company. You think, well, you know, as I said, you develop something, you produce it, you sell it, you deliver it, and then you don't get paid for, well, I like to say 30 days, but 45 days, 60 days. If you sell in Italy, 180 days, 300 days. You know, it takes a long time to really get the money back. So you need it takes a lot of money to actually keep a company going. Number of personnel problems. You know, and as I look back at WYKO and I compare it with other companies that I've been involved with since then, we didn't have that many personnel problems compared to what a lot of other companies had, but there's still a lot. It's just all kinds of little personnel problems that come up all the time. And they really do take a lot of time. So these are kind of the 4 biggest surprises I've had. You know, most important, you know, you have to have a product people want to buy. Often I'll be talking to someone, they have a great idea, something they want to build, and you kind of ask them, well, does it work? Oh yeah, it works. Does anyone really care that it works? Well, you know, there has to be something that people really want to buy. And that was where we were so lucky, especially on these microscope systems. We had something that no one else had for many years, and people wanted it. I mean, it was wonderful. You really have to be willing to do whatever it takes to get the job done. You may be the president of the company or whatever, but you have to, you know, whatever it takes to get it done, you have to be willing to do it. And the other one, you have to be good at hiring people, because you do so little yourself. I mean, it's really the company that you build, the people that you hire, that make all the difference in the world, because they are the ones who really determine whether the company is a success or not. Must have. I think you have to have absolute dedication to the company. You know, the first 2 years when we were trying to run the company, I was staying at the university and expecting Steve to do everything, just doesn't work. You really have to dedicate yourself to the company. You have to have good timing. That's so important. You know, things that we did in WYKO might not work now just because the timing is off. Most important, you have to be lucky. I think so many times that things have been, you know, just a little bit less luck. You know, it could have been a completely different situation, but we were just very lucky. So, you know, I could stop at this point, but I'm not going to. I have 4 more slides I want to show. And the reason is doing companies is a disease. You know, I sold WYKO, I went back to the university, and I'm having a fantastic amount of fun at the university. But then this guy comes along to me, Larry Johnson, and he had this story. I can't believe it's true. He's one of our graduates. He had this story. He said, you know, when you taught lab such and such, you wrote in my lab book that if I ever start a company and I need money, to come see me. You know, I can't believe I ever wrote that in that lab book, but he swears I wrote that in the lab book. But I liked the story so well, I got involved with ILX Lightwave shortly after Larry started the company. Because once he started, he realized you really do need a lot more money to make this go. So anyway, it's in a laser diode instrumentation test systems, and it's up in Bozeman, Montana. So, you know, you go from Tucson to Bozeman. There's a little difference in the temperature in the wintertime, but it's a lot of fun. We've had a lot of fun there, and we've kind of, I think Larry's kind of getting to the point now where he's thinking about cashing out, so maybe I'll be cashing out. But that's been a lot of fun doing that company. And then there's 4D technology. Now, this is fun. Back in my WYKO days, the biggest problem we had with our instruments was vibration. They were so sensitive to vibration. And after selling WYKO, I said, I'm going to solve this problem. And so when I went back to the university, I set up my research group to solve the problem we had with vibration. And, you know, we did a few, I think, 4 PhD dissertations on the topic. And we did things that worked well as far as writing papers, but they were not something that would ever make a commercial product. And then I heard about this company in California called 4D Vision. I heard they had come up with a way of getting around this vibration problem. And I went over there, and it was a 4-person company. And these 2 people, James Millard and Neil Brock, had come up with an extremely clever idea. And I loved it. It just worked so well. It was everything I dreamed about. And so we went out to lunch. And while we were eating our hamburgers for lunch, I made an offer to buy the company. And so it took a little time to work out all the negotiations, but now James Millard and Neil Brock are in Tucson, and the company here is in Tucson, and we've grown a fair amount. And James is the president, doing a wonderful job. It's fantastic, this instrument is. I could talk for a few hours about that, but I won't. The last slide here, is that we have a professor, associate professor, Mike DeScore, who came up with a very good idea for microscopes, for high-speed scanning microscopes, where basically we use a number of small lenses, and so we're taking a lot of data in parallel. And Mike got a patent on this, and we licensed the patent from the university and went off and started Demetrics. And so this is a really challenging instrument because the optics are challenging, the mechanics are challenging, the electronics are challenging, and the software is challenging. It's a really of the various companies have been involved with, this is probably the most challenging project or product, but it's a lot of fun. So anyway, with that, you know, I'll say thank you, and I really enjoy coming back here and talking about this. And for some of you, you know, if you're interested in starting a company, do it. It's a tremendous amount of fun. So thank you very much. you have any time for questions? Or? Okay.
You never had to start with any of these with venture capital, did you?
No, the first one was IBM, and then fortunately I made enough money from the first one, I did the other three.
That seems to be a big stumbling block
Yeah.
in the beginning for a small company.
It is, getting the money. In Tucson, there's a wonderful organization called the Desert Angels. And these are people who have made a fair amount of money, often in the real estate industry or something, but, and they love to invest in companies. You know, they don't invest a large amount of money, but enough to get it going. And so we were lucky in the way we did ours. Thanks to IBM, they were fantastic. Any other? Yes.
So there's a lot of photonics industry in Arizona.
Yes.
So what's the chicken and egg problem here? Did the university spawn that, or was it already there?
What was there first was the astronomy. And astronomy was very big in Tucson, and a man by the name of Aidan Minell came to Tucson to start Kitt Peak Observatory. And he got Kitt Peak up and going, and then he became the head of the astronomy department at the university. And he was the man who thought of, we need to have something in the university to do research and teaching in optics. So he started optical sciences. And now he thought that, that immediately a number of companies would spring up. And I think he was disappointed. 20 years went by and not much happened. But then after about 20 years, it began growing. And right now, the optics industry is doing very well in Tucson. But it took far longer than what Aidan Minell thought it would take. But I think maybe 20 years is reasonable. Yes?
You mentioned that 4D technology came up with a clever idea to get rid of the vibrations.
Mm-hmm.
What was the idea?
Okay, well, it was James Millard and Neil Brock came up with a way of, I'd have to get somewhat technical here, but it's this phase-shifting interferometry where we're taking several frames of interferogram data, and between the frames, we're changing the phase difference between the two interfering beams. They figured out a very clever way of taking all frames at once. Other people had come up with ways of taking all the frames at once, but not clever and not practical like their particular way. And I can give you all kinds of technical details later if you want. But it was James and Neil came up with this very clever idea. Mm-hmm.
First of all, thank you for the talk. Really quite inspirational. My question is, when you're trying to make that product for IBM, and after like 2 years, it seemed like it still wasn't working out. What motivated you to keep going? Why did you not give up and fold?
I don't want to fail. No, didn't want to fail. I mean, it was kind of scary to go part-time at the university. And, nowadays the university is encouraging faculty members, at least University of Arizona, encouraging faculty members to start companies. Back when I did it, they were discouraging it, and there was, my boss was threatening to fire me if I did this and whatever. And I just finally said, I can't fail. I have to do it. If I need a job later, I'll get a job someplace. Question?
So if you were a sprinter, would you have not made it?
Well, no. I guess running cross country is what did it. Yeah, that last mile. Yeah. I sometimes think about that as my life. As time goes along, I used to run the mile here, and that last lap. I mean, you run that as hard as you can, and so that's kind of the stage my career is in right now. So I'm running as hard as I can right now too. Yes.
It seems like your story is a bit unusual compared to most of the stories I've heard about people who come up with clever technical ideas. And that it seems like the normal path is at some point the person who comes up with a clever idea is booted out of the company by the people who actually know how to make money and do the marketing. And it seems like to actually have a good taste in your mouth and a good feeling and feel like you had fun all the way through, you need to figure out how to do it your way. Yeah. So what did you do that was so different that you ended up being the guy that cashed out in the end instead of having the people that became the presidents of the company kicking you out?
Well, I was lucky. First off, I didn't go out for outside money. I mean, and almost always you have to. I mean, you don't have a choice. You have to have money from some. IBM, I mean, this guy, Bharat Bhushan, I mean, he had confidence in what we were doing. And then IBM, so we got, 60,000 up front. And then we got money from other companies the same way. And I think it was luck, just very lucky. And so, I owned most of the company and I was the president, so there was no one to throw me out. So yeah.
All right, there's one more question.
One more question back here?
I just want to ask you, you have a lot of industry experience and a lot of academic experience. As far as compare and contrast, I guess the model as far as getting work done and efficiency that each realm requires?
Well, a lot of university experience, but in some ways, at least the way we operate at Optical Sciences, it's a little bit like a company in a way that very little of our money comes from the university. Most of it, 87%, comes from outside grants and contracts. And so each professor, in a sense, is, he has a little company at the university in a sense that he has his research group that he's responsible for getting the funding for. So that's a little bit like a company. I mean, I love both. I could have been very happy in life if I'd spent my whole life in industry, or I could have been happy if I'd spent my whole life at the university. But really having the two made it fantastic.
Great. Before we let you go, we'd like to want to thank you for a wonderful time and give you a few things to remember.
Oh, my, thank you. Yes. Thank you very much. Thank you. And thank you all for coming.